Okay, we're going to calculate an IROC expression for an exponential. It's going to be slightly different than the power functions that we were doing earlier, hence the stars. But we are still using the same IROC expression. F of a plus h minus f of a all over h. In this case, since x equals 5, our a value is equal to 5, which means our x1 value is 5, our x2 value is 5 plus h. So f of a plus h means plug in 5 plus h into our expression. So we're going to get 2 to the 5 plus h. 2 to the 5 plus h. And then we're going to subtract f of a. So we're going to plug 5 into our expression. So subtract 2 to the 5th all over h. Can we simplify that? A little bit. We know 2 to the 5th is 32. We could rewrite 2 to the 5 plus h as 2 to the 5th times 2 to the h, but it doesn't really help us very much. So we're just going to leave it like this. And since there's no h term in every, or there's no h in every term, we can't get rid of the h in the bottom. So our this is our final IROC expression. Now, to find IROC, remember we need to find the limit as h approaches 0 of our IROC expression, 2 to the 5 plus h minus 32 all over h. So we need to find the limit of that. The problem comes in when we try to substitute 0 in for h. If we divide by 0, we get an undefined term. And so that's not going to work very well. So instead of just substituting in 0 to find the limit, we could look at a graph. We could also consider the table of values. And so if we look at a value that's very, very close to 0, like 0.0001, and plug that in for h, that should give us an approximation of what we're heading toward for the limit. Now, with exponentials, you want to make sure you use a number that has several decimal places in it because exponentials grow really fast, right? So if we're going to plug in 0.001 into our IROC expression, we would rewrite it like this. 2, 5 plus 0.0001 is just 5.0001 minus 32 all over our h value, which is 0.0001. When I calculate 2 to the 5.0001, I get 32.0022. I'm going to subtract 32 from that. I'm going to divide it by 0.0001. And the top after being subtracted is 0.0022. Again, dividing by our h value. And when I do that division, I get an answer of 22. Therefore, 22 is equal to our instantaneous rate of change. And what that means is 22 is the slope of the tangent line at x equals 5 for our original function of 2 to the x.